Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to do a review of Unit 1 material for you. I'd like to start with electrical voltage sources. DC is direct current, AC is alternating current. In both examples I give you XY Cartesian coordinate system plots of voltage with respect to time. Time is on the horizontal or the x-axis. Voltage is on the vertical or the y-axis. In the DC case, notice the 12-volt signal has a constant amplitude or a constant magnitude independent of time, whereas in the case of the familiar AC sine wave, I start here with a value of 0 voltage. Here I have a maximum positive value of voltage. Here I return back to 0 volts. Here I have a maximum negative value of voltage, and here I return back to 0 volts. Couple things I would like to go over with you for the AC sine wave. From this point to this point, that's referred to as a cycle, and cycles per second is referred to as the frequency of the AC sine wave. In the United States, the frequency of the sine wave is 60 hertz. Frequency and time are inversely proportional, so time is equal to 1 divided by frequency. Frequency is equal to 1 divided by time. So if you would like to calculate how long it takes to complete one revolution or 160 hertz cycle, simply take 1 divided by 60 and it would give us 16.7 milliseconds. We have to go back in history a little bit. The Greeks studied electricity about 2,500 years ago, and they looked at static electricity. So static electricity, the most famous law is called the law of electrostatic attraction, which states like charges repel and unlike charges attract. So if I have two positively charged objects, that would be a force of repulsion. Likewise, if I had two negatively charged objects, that would also be a force of repulsion. If I have a positively and a negatively charged object, that would be a force of attraction. What I would like you to consider, in addition to the concept of a positive or negative charge, think of the idea of an excess and a deficiency of charge. So 3 practical examples I would like to give you for static electricity. Number 1 would be if you were to rub a balloon on your hair and then you would see the balloon sticks to the ceiling. Why does that occur? The process of rubbing the balloon on your hair, the friction, imparts a charge to the balloon or an excessive charge, whereas the ceiling has a deficiency of charge. So the process of sticking the balloon to the ceiling, balloon has an excessive charge, ceiling has a deficiency of charge. The second example would be lightning. We've all experienced lightning, I'm sure. Think of this idea of excess and deficiency of charge again. The most common lightning strike is going to be cloud to earth. But 2 other rare forms of lightning are earth to cloud as well as cloud to cloud. So consider this idea of excess and deficiency of charge. If the cloud or clouds have an excessive charge and the earth has a deficiency of charge, the lightning strike will occur from cloud to earth. If I reverse that, and for some reason the earth has an excessive charge and the clouds have a deficiency of charge, now the strike would occur from the earth to the cloud. Third example would be walking on a carpeted floor. If you walk on a carpeted floor and then you touch a metallic doorknob, you'll notice you may get a shock. And sometimes the voltage is so high that you'll see a spark, and that's actually called corona discharge. The voltage is high enough to break down the air gap. But what occurs, the process of your shoe rubbing on the carpet through friction imparts a charge to your person, so you have an excessive charge, whereas the metallic doorknob has a deficiency of charge. Atomic theory. We have to talk about an atom and the subatomic particles contained within the atom. If we consider the core of the atom is called the nucleus, within the nucleus we have protons that are positively charged subatomic particles and neutrons that have a neutral or 0 charge. We're really not too concerned about the protons and neutrons. We're more concerned about the negatively charged particle called the electron, and that revolves in shells about the nucleus. Of particular interest is the valence electron, and valence electrons would be the electrons in the furthest orbital out from the nucleus. Couple definitions you should understand. Atom is the basic building block of the universe. Matter is a physical substance that has both mass and occupies space. Matter can exist in three states: liquid, solid, and gaseous. And the best example of a chemical that exists in these three states at relatively close temperatures: water. Water in the solid state is ice. Water in the liquid state, of course, is water. And water in the gaseous state would be steam. The atomic number is the number of protons contained within the nucleus. I would also like to point out definitions for conductor, insulator, and semiconductor. A conductor is a material that has the ability to conduct electricity very easily. What are some examples? The copper wire that you use in your electrical lab, for example, 14-2 Romex or 12-2 Romex, the copper conductors are examples of conductors. Any metallic object would become a conductor. Insulator is just the opposite. If a conductor can conduct electricity very easily, an insulator cannot conduct electricity very easily. And examples of insulators would be nonmetals. Glass, porcelain, bakelite, and mica, for example, are chemical compounds that are used in a lot of electrical devices. Wood, if the wood is dry. If the wood is wet, it would act more like a conductor. Leather would be an example. Semiconductor. Semiconductor is a material that can behave like a conductor or behave like an insulator. Semiconductor materials are in your personal computer, they're in your iPhone. Any electronic device that you have will have semiconductor materials. So through a process called doping, the semiconductor material can be electrically biased in a way to act like a conductor, act like an insulator, or act like something in between a conductor and an insulator. And then the final topic I would like to mention, a definition for molecules. That is the smallest part of a compound. So two chemicals that I would like to give you that are standard items we use every day: H2O. This tells us that we have let's say 2 units of hydrogen, H2, and 1 unit of oxygen. Well, in that combination, H2O is water. The other example would be NaCl. Na is sodium and Cl is chlorine, so NaCl is ordinary table salt. Thank you.